Good day, students. I want to give you some support concerning exercise 3.4. Does democracy matter? And we have to do some replications based on table 5.13. The model which is suggested in the exercise is that we try to explain human development by using factors as affluence, investment, economic freedom, modernized leadership, and a democracy indicator. This one is constructed by Freedom House. And how should we do this? First of all, before we start, I created two variables that represent affluence. So that's the log transformed GNP per capita, and that's the log transformed GNP per capita squared. So this is representing affluence. So if we want to start this exercise, what we should do is go to analyze. We always use regression in these exercises. Go to linear regression. What do we want to explain? The human development. How do we explain it? First by affluence, so these two factors. We want to use investments, this is this factor. We want to use economic freedom, this one. And we want to use modernized leadership, this one. And the most important one, because the exercise is called Does Democracy Matter? We want to use this democracy indicator. So we're all set. Maybe we can use some correlation matrix. This one, leave it out. Durbin and Watson for, yes, you guessed it right, serial correlation, a check on autocorrelation. We want to look at some outliers, and it standardly sets itself, SPSS sets it on 3 standard deviations. Just for this example, let's use 2.5. Continue. Some plots. Now this one I always like to view if the residuals are normally distributed, and I think we're all set. I don't want to look at these DF betas in this exercise, so just leave it at that. Click on OK, and SPSS generates an output. The R square is, let's say, 93% of all variance can be explained by the model. The difference between R square and adjusted R square is that this one is based on the sample we used, and this one represents the whole population. So this the difference between R square and adjusted R square is some mathematical manipulation, but this one represents, if we want to express it verbally, represents the R square of the population, while this is for the sample we used. The model as a whole is significant, so that's nice to know. And here we have all our betas, and what can we see? All betas are significant with 95%, except one, the one we were interested in. And which one were we interested in? This was this one, FRIN 9195, this Freedom House democracy indicator. It's not significant with it, 95%. So does democracy matter in our example? No. Based on this statistical analysis, we cannot rule out with 95% that it doesn't have any influence. So this is what you verbally should understand about this output. These are the unstandardized betas, the standard errors of these betas, those standardized betas, and we learned you could see with these things, these standardized betas, you can look at the different betas and compare them and look at which one has the biggest impact. Now, by far, affluence has the biggest impact, and you see the smallest impact is for, yes, democracy. Okay, let us check some of the assumptions. First of all, Durbin and Watson. Durbin and Watson is quite near 2. So if it's very nearby 2, we don't have problems concerning serial correlation. Another thing, let's go down to the output. Oh, SPSS has to think a little. So, okay, here we are, SPSS. You see, the residuals are quite normally distributed, so we don't have problems there. Another thing, and this is a problem. In social sciences, they don't make a very big fuss of it, but you should know, if you look at this correlation matrix, what do we see? We see the correlation between the different variables. And there are, most of the time, not very big correlations. There's only one thing that troubles me. This is this number here, or this number here. Do we see those two numbers? This is the correlation between the log transformed GMP per capita and the log transformed GMP per capita squared. Those two have a very high correlation. So this is actually, you should say, there is multi-collinearity within this model. But because it is only in one indicator, we don't make a big fuss out of it. But pure statistically speaking, it wouldn't be right. So this is above 0.9, so we have problems there, but we don't make a big fuss out of it. Okay, we see there are 3 cases that have quite large standard residuals, or the cases have quite large or maybe can be pursued as outliers because they have they lie more than 2 standard deviations away from our regression. So we're not gonna fix these things, but more in the sense I just want you to get a little bit of feeling by how these things work. There was asked, look at the R squared, look at the T statistic. Now we all done that, but know that in our model democracy clearly doesn't matter. Okay, thank you for your attention.